Hey guys, welcome back to another video. This video is practice problems on alkene addition reactions. So let's get started. You can watch my previous video for an explanation on all these reactants, but this video will be just be going over practice problems for you all. So feel free to pause it at this point and write down this question, and then you can unpause it and see if we get similar answers. So let's get started. These show a lot of arrows and it wants the reagents for all of them. So let's start with this first reaction. We have a cyclohexene with a methyl group coming out and a bromine group coming out as well. And it goes into a double bond. So what would make that happen? This is actually this reaction is from our substitution and elimination chapters. So this would be an elimination reaction. Specifically, I guess it doesn't really matter if this is E2 or E1 because you would get they give you the same answers. It's just the mechanistic steps are different. So this one would take, let's see, we have a tertiary carbon that bromine is attached to. So we would need a strong nucleophile and strong base. So anything that has a negative charge, so we could do NaOET, we could do NaOMe, we could do NaOH, we could do any of those. So I'll just stick with that first one, and that would make that bromine go into that double bond. So that's that first one. All right, so we got that one out of the way. Let's go to the second one. We have this reaction right here where we have that double bond, and that double bond goes away. So it goes from an alkene to an alkane. There's one reagent that does that, and that's H2PT. You could also write H2PD as well. That's the same thing, but that reduces your alkenes into alkanes. Our next reaction right here, we have that double bond with a bromine on the more substituted carbon. So that's just a simple HBr. All right, we have a next one where that bromine is now on the least substituted carbon. Remember, this is a tertiary carbon and this is a secondary carbon, and it's going on the secondary carbon instead of that tertiary. So that would be the least substituted. So you need HBr and you need that ROR on the bottom of the arrow as well. Our next reagent that we're going to use utilizes that alcohol to go on the most substituted carbon. So you can use either H3O plus, or you can use HgOAC2, H2O, H2O2, NaOH. You can either use both of those because rearrangement, you can't rearrange this molecule, so you can use either or. I'll just use H3O plus because it's simple and easy. Our next one, our alcohol gets placed on the least substituted carbon. So that would be your BH3 times THF. What is on bottom? I'm mistaking myself. H2O2, H2O2, NaOH. So I was mistaken on the other reagent. It should be for this HgOAC, it should have a secondary step that's NaBH4. I got that mixed up. All right, our next one, we're adding anti-addition of 2 bromines. So there's only one reagent that does that, and that's Br2. So that's pretty straightforward. Our next one, we have a bromine and an alcohol being placed. That alcohol is at the more substituted carbon, so that would be Br2 and H2O. There is not a secondary step. You don't write 1 and 2. It's just like this. It all comes in one step. This next one, we're going from a double bond to a epoxide. And I said this in my last videos, there's one reagent that does this. That's MCPBA. That's one reagent you could use to go to an epoxide. All right, and then that epoxide goes into anti-addition here, so you just need a workup step to do that, and that's H3O plus. All right, You could also use, instead of MCPBA, you could write RCO3H. You guys learned that to be anti-addition as well, so that works as well. I'll use that one just because we learned it in this last chapter, and that MCPBA doesn't really get utilized till that alcohol chapter, so I'll use that as well. All right, we have syn addition here, right? This is syn addition because we're adding two alcohols and they're both either wedges or both dashes. So syn addition is OSO4, and I'm mistaken on the other reagent that's attached with OSO4 and H2O. And that's 2 steps there. You could also use a reagent that starts with KMnO4 as well. There is another reagent you could use there. Next one, we have this double bond being broken, and that is only one reagent that you guys have learned. That's oxidative cleavage. So that's O3-DMS. So right here, where is it? Right here, that double bond gets broken, and that O3-DMS makes that into 2 different alcohols that's double bonded to whatever is on each side of that double bond. So you guys can see this list of reagents in my last video. I think it's helpful to write out on a sheet of paper all the reagents that you learned for each chapter, just so you got them all in order. So this is going on to more one-step synthesis for alkenes. So this one, we have a secondary carbon and a tertiary carbon. So that alcohol gets placed on the secondary carbon. So we want to use BH3, THF, H2O2, NaOH. And feel free again to pause if you want more time. We have a Br being added on the more substituted carbon, so that's just HBr. And then a Br added to the least substituted carbon on this one. Remember, this is a tertiary, and this is a primary, so a least substituted carbon, that's HBr with that peroxy acid. We're going from an alkene to an alkane. So when that double bond, it looks like it disappears, we use that H2PT. For this one, we're adding a chlorine to a more substituted carbon, right? This is a tertiary, this is a secondary. That's HCl. And for this one, we're adding an OH to the least substituted carbon. This is secondary, that's tertiary. So that OH, again, we're using that same reagent that we used to start this page. At BH3, THF, H2O2, NaOH. Okay. So that's that one. This one is going into multi-step synthesis, and you can just worry about how we get to one of these. So feel free to erase this arrow, but pause it and think about the multi-step synthesis it would take to do this reaction. So I'll start with this one. We have a Br being placed into a different carbon. So this is on the second carbon, and we have it on carbon 3 in the product. So how do we do that? So the first step, I would say, let's get a double bond. So we want a reagent that does this, right? Because then with that double bond, we can put the Br onto that double bond, and it'll look something like this. So how do we do that? How do we get that Br away and make sure it's on the more substituted carbon? Well, we look at our substitution and elimination chapter and realize we just need a strong base, or a strong base / strong nucleophile. And that could be NaOET, that could be NaOMe, whatever works. And then from here, we're adding a Br to the least or less substituted carbon. So we have to use that peroxy acid, HBr, and ROOR on bottom. All right, this is more multi-step synthesis. So let's focus on C right here. Feel free again to pause it if you want more time. I'm going to show it without the stereochemistry, so without those wedges and dashes. I think that just makes it look a little more simple. So we want a reagent. we want to get that Cl away. So we have only really learned one way to get that Cl away, and that's by putting a double bond right there. And then our product shows no double bond, so we want no double bond at the end. So we'll end up with something like this. And I'll include those wedges as that. So what's one way that we just did to get that halogen away, and in place of that we get a double bond? Well, we use a strong nucleophile, strong base that we used in our substitution and elimination chapter. This would be an elimination reaction because we're ending up with a double bond. And then how do we go from alkenes to alkanes? We use that H2PT. So that's the C problem. Pretty straightforward. All right. Now let's focus on D. For D, we're starting with a phenol. So we're starting with an OH group on top, and then we're ending with two OH groups that are syn addition. So that's very important. We need to choose a reagent that's syn addition, and we only have really one that we learn. It's that OSO4H2O. So we know we have to use that. So let's write that on our products. We have OH, another OH, and we know our reagent has to be OSO4 and H2O. So what would that be before you did any synthesis? That would just be a double bond, right? Because we just worked on alkenes only, so that would just be a double bond. So now our one step that we haven't figured out is how to get to this from this alcohol to this double bond. And if you guys remember your reagents, you know that's going to be concentrated H2SO4. And it has to be concentrated. It can't just be H2SO4, because your professor would be like, oh, are you talking about concentrated H2SO4? Or are you talking about dilute H2SO4? Because those are two different things, so you have to specify in your reagents. So that is your synthesis for that one. All right. That is the end of this video. Hopefully this helped. My next video will be going into alkynes, so triple bond reactions, and I'll see you guys in the next